Hi, welcome to lesson 27, session 2. Today we're going to be continuing our work with line plots. And today we're actually going to learn how to make a line plot. And we will be using those benchmark fractions that we talked about to go ahead and create these line plots that will help us to analyze the data that we collect. So we're going to be working in our Ready Classroom Math Workbook on pages 557 through pages 562. So go ahead and take out your Ready Classroom Math Workbook and turn to page 557. And my dot camera has been really annoying today, so it has been not focusing very well. So I hope that it will work better today. All right, so we are working on lesson 27, and it says this. Read and try to solve the problem below. Kira bought 12 different types of stickers to decorate her scrapbook. She measured the width in inches of each type of sticker and wrote down the results. Make a line plot to organize and display Kira's data or data. All right, so let's go ahead and first figure out what in the world are we talking about. So what we are talking about is, let's see again, Kira bought 12 different types of stickers to decorate her scrapbook. She measured the width in inches and of each type of sticker and wrote down the results. Make a line plot to organize and display Kira's data. So first of all, we are talking about the width of stickers. Now the nice thing is here that we have over here where our data is, we have a title that tells us what it is that we're talking about. So we're talking about stickers and how wide they are. Now, what is it that we're trying to do or solve with this problem? We're actually not trying to solve anything. All we're trying to do is take all of the data and organize it on a number line. And then finally, what is the important information? Well, we know that we have 12 different types of stickers, and then we know that all of these stickers are over here. That's a really sorry star. There we go. All of our data is over here. These are our 12 width of stickers in inches. Now, here's what we need to do to create a line plot. The first thing we need to do is collect our data. So the nice thing is all of our data is already here and already collected for us. So there's not much collecting that we need to do. But if you were doing a survey or something and you were collecting your own data, you would need to have your data first. So here is all of our data. Then this is not necessary, but this is something that I like to do because I feel like it just makes it work better in my brain, but it is definitely not something you have to do. I like to order my data from least to greatest. Again, this is totally up to you whether or not you want to do this step. It's not 100% necessary, but it is something that you can do. Then you're going to, once you have all that data, you're going to draw your scaled number line. Fourth, you're going to label your data points. And finally, you're going to label your number line with a, let me put a space in there, not with a, with a title and label the units. Now that seems like a lot. And again, it seems like it might be a little bit extra, but I promise you that if you just follow these steps when you create the number line, it will make your life very easy. The only step that I would say is maybe possibly a little bit like if you want to or not would be step 2, but I would definitely do the other steps. So first of all, let's follow our steps. We're going to collect our data. So we have our data collected here. We're going to go ahead and order this data from least to greatest. The way that I like to do this is I like to actually go ahead and look and go, okay, what is the smallest value that I see here? So starting at 0, I'm looking for the smallest the smallest denominator, because remember, the smaller the number is, the smaller the denominator is. I mean, the smaller the denominator, it's like the smaller the units. So I can see here that 1/8 is definitely my least data point. And then I'm going to cross it out so that I don't accidentally try to count it again. Then, if I'm using my benchmark fractions, I know that I'm going to go ahead and have it be in eighths. So if I'm looking at eighths, then do I have any that say 2/8? Well, I don't see any that say 2/8, but I know because of my benchmark fractions that 2/8 is equivalent to 1/4. So I'm kind of going to go in this order to see what comes next. So I've already have my eighths. Now I'm going to look and see if I have any fourths. Do I have any fourths? I do. I have 1, 2. So I'm going to write 2 1/4 when I'm putting my data in line. Again, this might not be the best for you, so it's okay if you skip this step. After I've got my fourths, then I'm going to go ahead and look and go, okay, what's next? After 1/4 is 3/8. Do I have any 3/8? Oh, I do. 1 3/8. Do I have any halves? Let's look. I have 1, 2, 3 halves. So 1, 2, 3 halves. Do I have any 5/8? Oh, I've got one. 5/8. Do I have any 3/4? I have 2. 1, 2. And then I have no 7/8, but I do have 2 wholes. So I'm going to go 1 and 1. Now, to double check that I have all of my data points down here, I know that I should have 12 because that's what it said in the question. So I'm going to go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Now I have all of my data ready to go. Now I'm going to draw my scaled number line. I know that I need to have a data point at an eighth. So, and all of these fractions can be made into equivalent fractions of eighths. So I'm going to go ahead and draw my scaled line starting at 0, because 0 is where we're going to start. And then our largest number is 1. So I'm going to stop at 1. And then I'm going to break my whole into eighths, because I can tell that I need my scale to be 1/8. So I'm going to write over here, scale of 1/8. And then what are we talking about? Oh, that's right. We're talking about inches. So the scale is 1/8 of an inch. So then I know that halfway is going to be 1/2. I can break that in to 1/4 and 3/4. And then I can break each of those into eighths, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So now I've drawn my scaled number line, and my scale is to 1/8 of an inch. Now, I'm going to label my data points. So I'm going to go ahead. And this is where having it in order helps. But you can also see after we do this that if you didn't have it in order, it would be fine. You could still do them and put them on your number line. It might just be not as organized. So how many eighths do we have? We have 1. So I'm going to show 1/8. I'm going to put 1x because I have 1/8. And then here you could even cross that out if you would like. Then I have 2/4, so I'm going to put 2 x's. above the fourths. I have 1 3/3/8. I have 1 2 3 halves. 1 2 3 halves. I have 1 at 5/8. I have 2 at 3/4, and I have 2 at 1. Now, as you can see, I skipped over this 7/8. Why did I do that? That's right, I had no values that were at 7/8, but I couldn't just not put it there because I wanted my number line to stay scaled. So it had to go from 0 to 1 and go up by 1/8 each time. So even though I have no values at 7/8, I still have to label the 7/8 and put the value there, even though I have no data at that point. And then finally, for step 5, I'm going to go ahead and label the number line with a title and then label the units. So the title here, the title's super easy. The title is just whatever your data was called. So in this case, it's going to be sticker widths. And then we're going to label, so the title usually goes at the top of the number line. And then underneath is where we have our units, where what we're talking about. So we're going to say this is widths in inches. So in other words, we know that each of these values down below is the width in inches of the sticker. So that is how you make a line plot. Again, if you choose not to put them in order, it really is okay because you could have just labeled, like I could have said 1/4, okay, 1x on 1/4, 3/4, 1x on 3/4, and then gone back and forth. It would have worked. But this is kind of a fun habit to get into of practicing putting your fractions into order from least to greatest. And remember, you can always use your benchmark fractions to help you know what is least to greatest. All right, let's go ahead and go to page 558. On page 558, it says we can explore different ways to make a line plot. List what we know and plan how to make the line plot. So the fractions are in eighths, fourths, and halves when it's describing all of the data here. The narrowest sticker, or the sticker that has the smallest width, is 1/8 of an inch. We found that out because it was the closest to 0. And the widest sticker is 1 inch. That is the closest to 1 inch. The line plot will start at 0 and go to 1 because we know that we need to start at 0 and we can go up to 1 inch. The line plot will show an X for each of the 12 stickers. The line plot will have a title and a scale label. Now, in this model, it says use your plan to start labeling and marking the line plot to display the data. Draw a number line from 0 to 1. So we have the number line from 0 to 1. We need to choose an appropriate scale for the data, graph each data value. The line plot below shows the first row of Kira's list of sticker widths. So they didn't put their stickers in order. So that's good because we can practice what that would be like. And then you'll decide if you prefer to put them in order first or if you prefer to just do it from the sticker widths. Now, we're not going to actually do this yet because it's part of what we're going to do over here when we get to number 5. So we're just going to go ahead right now and look at number 1 on page 559. It says this, look at the first model it. Why is it a good plan to go from 0 up to 1 inch for the line plot? So I wrote, all the stickers are between 0 and 1 inch wide. So we need to show from 0 to 1 inch. Also, when we're drawing our scale, this is just extra information. You can start writing this down. When we're trying to draw it to scale, we need to make sure that we have that 0 there so that we can see what the scale of the line plot will be. Number 2, speaking of scale, what scale is used for the line plot in the second model? Explain. So we recognize that we used a scale of 1/8 because we used a scale of 1/8 because there are 8 equal sections from 0 to 1 in our line plot. So we have 1 section, 2 sections, 3 sections, 4 sections, 5 sections, 6 sections, 7 sections, and 8 sections. So each of these represents 1/8. So the scale is drawn using 1/8 of an inch. So what does this scale, why does this scale make sense for this data? The scale makes sense because all of the stickers can be shown in eighths. So even though we have data like this, it says 3/4, we know because of our benchmark fractions, which is on the back of this page, we know that 1/4 is the same as 2/8. We know that 3/4 is the same as 6/8. We know that 1/2 is the same as 4/8. And so we know that all of this data can also be represented in eighths. So the scale makes sense because all of the stickers can be shown in eighths if we change their value. Or not change their value, but change their equivalent fraction. So the tick marks in the second modelet, that's down here, are not labeled with fractions. So even though you know how I feel about labeling those fractions, these ones are not labeled. Now it says here, do they have to be labeled? How can you locate data points with X's when the tick marks are not labeled with numbers? So you don't have to label. You can count and see that the scale is 1/8 because we could count the tick marks and go, well, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 tick marks. So we know that the scale is from 0 to 1 would be 1/8. From this one to this one would be 2/8 or 1/4. From here to here would be 3/8. From here to here would be 4/8, which is the same as 1/2. And we could keep going. So we don't necessarily have to label. However, you know me, I love to label. So I would prefer to label it just to make sure I don't make any mistakes and to help it stay in order. But again, you do not have to label. You could count and this to see what the scale is and then use that information to figure out what the data points are. So now for number 5, we're going to go ahead and complete the line plot in the second modelet. We're going to include the rest of the data. We'll give it a title and a line plot above the line plot, and we'll label the scale below the line plot, which is all something we did on the last page, so I'm going to go through it rather quickly. I really want to label this, so I'm going to go ahead and label it. So this would be 1/8. I'm going to change this to 1/4, excuse me. I don't want to write it as 2/8. I want to say it as 1/4 because I know that it's 1/4. 1/4, which is equivalent to 2/8, 3/8, 1/2, which is equivalent to 4/8, 5/8, 3/4, which is equivalent to 6/8, 7/8, and then 1/2 is already labeled. Again, we don't have to, but I just feel better labeling it. So I'm going to. Now, they've already done 1/4, 3/4, and 3/8 for us. 1/4, 3/8, and 3/4. So as you can see, they didn't put them in order, but they did label those for us. Now we're going to do this 3/4. So we'll come down to 3/4 and we'll put another X above 3/4 and then cross out 3/4. We'll do 1/4. We'll put another X above 1/4 and cross out this 1/4. We'll do 5/8 by coming below, putting an X above 5/8, and I already crossed it out. Here is 1/8, put an X above 1/8. 1/2, put an X above 1/2. 1/2, X above 1/2. 1/2, a third X above 1/2. 1/2, X above 1/2. 1/2, X above 1/2. I know that I have 12 pieces of data. I always like to count my X's to make sure I have enough X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So now I've labeled all of my data. Now I'm going to label my graph. I'm going to use the same title they used up here and call this sticker widths. And then my unit, I'm going to label down below. I'm going to say this is the width in inches. So the data looks the same as what we did on the previous page. The only step we skipped was step 2, but with ordering the data from least to greatest. And quite frankly, now that I've done it, it was a little bit easier in this case to just match the data and not do that step. It just saved me a lot of time. So in the future, maybe over the next week, you might also find that you don't need that extra time to put that in order. Now, when we go back, let's look over at this reflect. It says, when looking back at the try it strategies by me, not your classmates, and model it, which models or strategies do you like best for making line plots? So when making a line plot, I like to, what is something that you think that you will want to do when you are making a line plot? Go ahead and write that down here. And when you're done, you can pause the video to finish. And then when you're done, you can turn with me to page 560. All right, on page 560, we see this question here. It says this: Sean records the length in inches of several bugs he collects for for a science project. Complete the line plot of the data or of the data. So this time I'm going to follow my instructions, but I am not going to order from least to greatest because I don't think that that's going to benefit me today. So I'm going to look at all of the data that I have. I have lots of different numbers here. Let's see how many values we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 pieces of data. So we are going to have 10 X's. Next, we need to go ahead and draw a scaled line. Right now, it is scaled from 1 to 4. But I really feel like we need to break this apart. So what if I were you, what I would do is look at all of your denominators and find the largest denominator. That's right, it's 8. The largest denominator is 8. So we're going to break each of these sections into eighths. We're not going to break the whole scale into 8 because we're going to break it into eighths between each whole. So if I broke it in half, this would be 1 1/2. This would be 2 1/2. This would be 3 1/2. Then I'm going to break each of those halves into fourths. This would be 1 1/4, 1 3/4, 2 1/4, 2 3/4, 3 1/4, and then 3 3/4. I'm going to then break it into eighths, but I'm not going to label each of those eighths. I know that they equal eighths, but I don't want to muddle it up by trying to write all of those eighths in there. So I'm just going to leave my fourths and my halves and know that all of these tick marks that go in between are eighths. Once I have all of that done, then I'm going to come up and start with my first data point and decide where that goes on the number line. So the first one that I have is 1 5/8. So I'm going to go to my 1. And then if you don't know where 5/8 is, and by the end of this, you probably will, but if you don't know where 5/8 is, all you need to do is count each tick mark, starting with the first one, and count up to 5/8 because we're already at 1. So 1 1/8, 1 2/8, 1 3/8, 1 4/8, 1 5/8. So we will put our first data point above this tick mark, which represents 1 5/8. Then cross out 1 5/8. Now we'll do 3 1/4. So we're going to go to 3, and then we actually have that one labeled. So we're going to go ahead and put an X above 3 1/4. 1 3/4. Oh, we have that one labeled because we know that we labeled all the halves and the fourths. 2 7/8. I'm going to go to 2. And then I happen to know that 7/8 is the last benchmark fraction before we get to 3. So I know that right here is my 2 7/8. I also know that 3/4 is equivalent to 6/8. So 2 3/4 is the same as 2 6/8, which means that this tick mark here is 2 7/8. We have another for 1 3/4. So I'm going to put another X above 1 3/4. 3 and 1/4, another x above 3 and 1/4, another x above 1 and 5/8, which, if you remember, was back over here next to between 1.5 and 1 3/4, is 1 and 5/8. We have 2 and 3/8. 2, I'm not quite sure where 3/8 is, so I'm going to go ahead. Let's get this to focus before I start. I'm going to go to 2, and then I'm going to count up by eighths to 3/8. 2 and 1/8, 2 and 2/8, 2 and 3/8. So here is going to be my 2 and 3/8. I have 1 at 1, and then finally another value at 1 and 3/4. Next, I'm going to go ahead and label this graph. Now, I don't know what the label is because this data did not have a label, but it says here that he records the lengths in inches of several bugs he collects. So this is the length of bugs is the title of this graph, of this line plot. And then the unit that it is in is it's the lengths in inches. So we're going to write lengths in inches. I think that worked pretty well, not putting those in order. And I think it might have taken you a little bit of time to put them in order. So don't worry about that step. You can just go ahead and put them straight onto the line plot. Looks pretty good. All right, I'm going to do one more with you. I know this video is getting a bit long, so I'm going to try and move through this a little bit faster. But we are going to go ahead and do number 9, and then I will send you on your way to do pages 561 and 562 on your own. It says this: Dolores trains for a 5-mile race. She keeps track of the distances she runs each day in miles in a training log. Use the data to make a line plot. Show your work. So we're going to look, and we're going to quickly look and kind of see what is the least value we have on here. So I see some 7s and 5s and 6s and 5s and 7s and 6s and 4s and 6s and 5s and 5s and 7s and 6s and 4s. So I'm going to go ahead and start this line plot at 4 because the smallest value I see is this 4 and 1/4 or the 4 and 3/4. Those are the two smallest values. Now, the greatest value I see a 7 and 1/4, another 7 and 1/4. Now, can I stop at 7? No, I cannot stop at 7 because 7 and 1/4 is actually greater than 7. So I'm going to go ahead and go all the way to 8. Now, I'm going to go from 4 to 8. So I'm going to go ahead and label. I already have 4 and 8 labeled. I need to label 5, 6, and 7. So I know that halfway would be 6. Halfway between 4 and 6 would be 5. And then halfway between 6 and 8 would be 7. Then I'm going to label halfway between each of those. 4.5, 5.5, 6.5, and 7.5. Next, I'm going to label fourths. Or do I need to? Do I have any values that are in eighths? I do not. So I'm actually not even going to actually label the fourths. I'm simply going to put a tick mark in between each of the halves, and that will be represented of fourths. And I'm going to know their fourths because it's halfway between. So I know that 4 and 1/4 is halfway between 4 and 4.5. And I don't want to label it because it is going to make that number line look a little muddled, as I mentioned before. So now that we have our number line labeled, we're going to go ahead and put all of these points on the data, all these data points on the line plot. So 7 and 1/4. I'm going to come to 7. I know that this is 7 and 1/4 because I didn't label it, but I know that all of the ones that are not labeled on my graph are all fourths. So 7 and 1/4 goes here, and then I'm going to cross out 7 and 1/4. Then I have 5. 5 is here. Then I have 6.5, 6.5, 5.5. I have that labeled, 5.5, 5, 7, 6, 4 1/4, again, 4 1/4, 6 1/2, 5 1/2, 5, 7 1/4, 6 1/4, 4, and 1 2 3 fourths. So I should have 14 X's because there's 14 days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Now I'm going to go ahead and give my line plot I'm going to give my line plot a title. And this is going to be distance run each day. And then the unit is in miles. So we're going to write distance in miles. So there you go. That is how you create a line plot. First, you collect your data. Then I'm going to go ahead and say sometimes you could order your data from least to greatest, but we're not going to do that for today and for this week. So first, collect your data. Second, draw your scaled line. Third, label your data plots on the line. Fourth, give your line plot a title and label it in units. And with that, you're going to go ahead and do pages 561 and 562 on your own, and then you will and then you will be good to go. I'll see you next time.